Okay, back to basics, learning channel. Back to basics, learning. Now, today we're going to talk about factoring, and we're going to talk about different kinds of factoring, but this first video, I'll just talk about finding the greatest common factor, factoring through finding the greatest common factor. So we'll do that, and then I'll do a couple of other videos on difference of a perfect square, and then the product of two binomials. These are the three ways to factor. Alright, so the first one here, GCF. Let's look at some of this. 2a plus 2b. Okay, so the teacher tells you to factor. How do you do this? First of all, you must understand that factoring is a form of reducing. That's what it is. It's a form of reducing. So we have to say to ourselves, what can go into 2 and what can go into a and b? Because we have two expressions here. We have the 2a and then we have the 2b. Those are two expressions, two monomials. And we have to ask ourselves first the number, then the variables. I tell students, first think about the numbers, then think about the variables. So what could go into 2 and 2? Obviously 2. What could go into a and b? Well, nothing. Because it has to be able to go into both. And you know, a can go into a, but a can't go into b. And b can go into b, but b can't go into a. So therefore, we can't use the variables. So it's just 2. Now I divide in. 2 into 2 is 1. You don't have to put the 1 there, unless there's nothing there completely. But I have an a left over, so I don't have to put a 1. 2 goes into 2 once. I don't have to put a 1 there because the b's left over. So there's your answer. 2a plus b. Ta-da! All right, let's do an easier one here. Another one, I should say. 8m plus 8n. Let's look at the number. What could go into 8 and 8? Obviously 8. What could go into m and n? Nothing, because m could go into m, but m can't go into n. And n can go into n, but n can't go into m. So therefore it's just 8. 8 into 8 is 1. We're not going to put the 1 because we don't need to, because there's an m left over. And then you divide into m. 8 into 8 is 1 with an n left over. 8m plus n. Okay. 2 x squared plus 5x. Okay. What number can go into 2 and 5? Nothing. Nothing. There is no number that could go into 2 and 5. What could go into x and x? X. X. Right? You always have to go, by the way, if you have the same variables in both expressions, you have to always go with the exponent on the variable that is the lowest. Alright? Because, see, x can go into x. But if I put 2x, 2x can go into x, but 2x can't go into x, you see? So that's why you have to just put x, because x can go into 2, x can go into x squared, and x can go into x. I meant x squared, not 2x. Let me say that again. What I mean is that x can go into x, and x can go into x squared, but if I were to put x squared cannot go into x. It can only go into x squared. Alright, so we have to choose the lowest that can go into both. Anyway, x into x squared. What you do when you, because this is division. When I divide exponents, variables with exponents, I subtract the exponents. So this is really x to the first. Now I have the 2 left over, so I bring that down. And then x squared minus x is x. 5 left over. X minus x1 minus x1, nothing. That's your answer. X, 2x plus 5. You don't have to put the 1. I just did that. Okay, let's go to another one. Here's a good one. Okay, What numbers can go into 10 and 5? We have to pick the biggest number, the greatest common factor, the greatest number that can go into 10 and 5. 5. 5. What can go into x and x to the third? X. That's it. 5 into 10 is twice. x1 minus x1 is nothing. 5 into 15 is 3. X to the third minus x to the first is x to the second. Done. Does that make sense? Because it was x to the third minus x to the first. So you subtract. That's a good one. Here's one that some students go crazy with, but pi r squared plus pi rl. So it's all variables with two symbols, the pi's. Anyway, we don't have numbers here except for the ones in front of here that are invisible, but they're really there. So what could go into pi and pi? Pi. What could go into r squared and r? R. What could go into L? L, but there's no L here, so you can't do it. Pi minus pi, nothing. Because it goes in once, it disappears. It's like pi minus pi, nothing. R squared minus R1. R, 2 minus 1 is 1. Pi into pi, gone. R1 minus R1, gone. L left over. R plus L. Okay. Let's look at this one here. Let's do one that's a little more complicated. AY minus 4AW minus 12A. Okay. Really, there's a 1 here. What could go into 1, 4, 12? Nothing. It has to go into all three. A number has to go in all three. There's nothing. What could go into A? A. What can go into Y, W? Nothing. So A is the common variable for all of them. A minus A, nothing. Y left over. 4 is left over here. A minus A is nothing. 4W is left over. A goes into A, nothing. 12 left over. That's your answer. Y minus 4W minus 12. Let's do another one here. Here's it going. Do a couple more. Okay. What number could go into 3, 6, 30? 3. 3, absolutely. 3 into 3 goes once, because there's nothing that can go into x, x, and nothing. So I know it's just a number. 3 into 3 goes once with an x squared left over. 3 into 6 goes twice with an x left over. 3 into 30 is 10. Ta-da, that's it. Actually, you could actually go further, I think. Let me see. Product of two binomials, 5 times 2 would be 5, 2, 7. What two know 5 and 2? That'd be 7, 2. No, it wouldn't work. I'm sorry, I'm just thinking if I could further factor that, but I can't, so that's it. Alright, here's another one. 8a for b squared c to the third plus 12a squared b squared c squared. Okay. Now there's a lot going on here. So we do numbers first, then the variables. What could go into 8 and 12? I think 4. Yes, 4. What could go into a to the fourth and a to the second? We use the lowest variable. So I would say a to the second. Because they both have a's, so they'll fit in. What can go into b to the second and b to the second? Only b to the second. What can go to c to the third and c to the second? C to the second, because that's the lowest one. 4 into 8 is twice. A to the fourth minus a to the second is a to the second. B to the second minus b to the second is nothing. It disappears. C to the third minus C to the second is C. 4 into 12 is 3. A to the second minus A to the second is nothing. B to the second minus B to the second is nothing. C to the second minus C to the second is nothing. Boop, that's it. 2A squared C plus 3. I hope we're getting this at home. This is really not bad. Just divide in, subtract, see what's left. Let me do one more here. Big guy here. 15 x to the third y to the third z to the third minus 5x y z. What could go into 5 and 15? 5. What could go into x to the third and x? X. What could go into y to the third and y? Y. Oh, what am I doing? Excuse me. I don't need the parentheses yet. What could go into z to the third and z? Z. Now I divide. 5 into 15 is 3. X to the third minus x to the first is x to the second. Y to the third minus y to the first is y to the second. Z to the third minus z to the first is z to the second. 5 into 5 is 1. X into x cancels out. Y into y cancels out. Z into z cancels out. So in this case, you have to put a 1. Remember I told you don't have to put a 1 if there's a placeholder? You cannot just have this. You have it's a binomial, so it has to stay a binomial. And since 5xyz goes into 5xyz, it's a 1. Just make that a little neater for you to understand that. Okay? I hope that makes sense. Alright, so this is factoring with GCF. It's pretty simple. Alright, the next video I'm going to do is difference of a perfect square. Back to basics learning. I'm out.